Welcome to Intergalactic Media Visualization, or IGM-Vis. We're going to demonstrate some of the main features of IGM-Vis and orient you to the interface. The dataset we're using here is a combination of QSO spectroscopy from the Hubble Space Telescope, represented by these skewers through the 3D space in the Universe panel, and galaxy measurements from the Sloan Digital Sky Survey, shown as red and blue points to signify star-forming and non-star-forming galaxies. In the Universe panel, we do see the skewers, the QSO spectra here, all throughout the volume. You can see the galaxies interspersed among them. So we're zoomed way out here to see the full view of the data set. This is representing approximately 25% of the night sky, so it's just a huge amount of data. And we can play with the graphical interface just a little bit here, customize colors, change the sizes of the points of the galaxies, etc. We can turn the skewers off. We can also turn the text labels of the QSO sightlines on and off. And now we're looking at the galaxies alone. You can see the large-scale structure in the universe in this dataset volume. Most notably the Coma cluster as the big, bright cluster of galaxies here in the middle of the screen. So now we can play with the colors of the skewers themselves. The skewers are representing the spectroscopy of background quasars that are piercing through this volume. So you can see certain bright points that correspond to absorption lines, and those absorption lines we're going to use to trace the intergalactic medium and circumgalactic medium. We'll zoom through here and select skewers. You can see the spectrum in the upper right corner of the screen. This is the spectrum panel. You can see the spectrum here changing when we hover over various sightlines, and individual galaxies that are near the sightlines will show up as these vertical little hash marks overplotted on the spectrum. And we can select galaxies to save down in the galaxy panel. Here we see several characteristics of the galaxies. From the galaxy data, their coordinates, the mass in stars, the star formation rate, as well as their virial radius. So we'll now select several of these skewers and save their spectra in the spectrum window. We can use this to select a sample of sightlines for which we want to analyze. We can modify the impact parameter range around which we mark galaxies in the spectrum window. So we can go out to very large impact parameters. As you can see, it populates more and more galaxies, or we can limit our impact parameter range. We can also map the heights of these lines based on various attributes. The default is the distance from the skewer, so a taller line corresponds to a galaxy closer to the sight line. But we can also use attributes such as the stellar mass of the galaxies to show that more massive galaxies near the sightlines will have taller markers on the spectra. We can modify the widths of those lines if we want to map that to, say, the stellar mass or even the distance from the skewer. The default is 1 pixel wide. By default, the spectrum panel shows the full redshift range of our data set. However, we can zoom in on certain spectral regions to inspect absorption features or perhaps several galaxies that may be near the sightline, giving rise to the absorption pattern seen in the spectrum. We'll now measure some equivalent widths of these absorption lines. We'll start by pressing the E button, click once on the left-hand boundary of the absorption feature, press E again, click on the right-hand side, press E once more, and then click on the center point of the absorption line, which will be the reference redshift of the measurement. So we see the equivalent width panel being populated by these equivalent width measurements as we go through each skewer and measure various features. Now, if we have significant absorption, the point will show up as a data point with error bars. If there is no statistically significant absorption, the point will show up as an upper limit, which will be a point with a downward-facing arrow. Now we're going to apply IGM-Vis to test a scientific hypothesis corresponding to use case 2 in our paper. The The bright, most conspicuous cluster of galaxies seen here is the Coma cluster, at the intersection of several cosmic web filaments. Our hypothesis states that galaxies within the filaments in closer proximity to Coma have been stripped of their circumgalactic medium gas, their CGM gas, more so than galaxies in filaments far away and in less dense environments. So we are going to select skewers that have nearby galaxies and hence probe their CGM in filaments both close to and far away from Coma. And for each of these galaxies, we're going to measure the equivalent width of the spectrum at similar redshifts to these vertical hash marks we see in the spectrum panel. So we're going to go first find several of these skewers throughout the volume. Here's another. So we define filaments as these long, sort of elongated structures of galaxies that compose the cosmic web. And at the intersections of these filaments, we form galaxy clusters, such as Coma, seen here. We'll measure this galaxy, and the size of the vertical size of this line is relatively small, representing a large impact parameter, so the large projected distance of the galaxy from the sightline. And as we measure the equivalent width, we can see the data actually plotting the equivalent width impact parameter plot down in the bottom of the screen near the center. And there's no detectable absorption signature at the redshift of the first galaxy, these either. And we see them populating as upper limits. Quite a strong signal here associated with several galaxies. So we'll go ahead and measure this absorption feature. First, click on the left-hand boundary of the absorption line, now the right, and now click the center point of the absorption line. And this will provide the reference redshift for the calculation, and that's all done under the hood here. And you see we actually have a detection, so the point shows up with error bars in the equivalent width plot, as opposed to the downward-facing arrow, which shows an upper limit. Okay, very tall vertical line here on the spectrum in the region of this next sight line. This represents a galaxy that's very close to the sight line. It's a very small impact parameter. Once again, no discernible absorption, so this will show up as an upper limit. Okay, I'd selected this particular skewer, but there's no galaxies that actually fall within our impact parameter range set by the slider at the bottom. We're going to go ahead and find another skewer that pierces a filament near Coma, but has some more galaxies where we can repeat this process, adding more equivalent width points.